You know that feeling, right? You walk into a big, expensive boardroom, you fire up your presentation, and the huge 4K screen just looks a little
A
off.
bit washed out.
Yeah, or the text on your spreadsheet is like slightly fuzzy.
The dreaded chroma crunch.
Exactly. And we always blame the screen or maybe the cable, but uh, a lot of the time, the real bottleneck is this invisible hardware that's running the whole show.
Mm-hmm.
And that's why today we're doing a deep dive into this one piece of gear. It's the Kramer MC3-2HO. It's a 4K 60 HDMI output card. And it's basically the gatekeeper between okay video and true studio-grade quality.
It really is. And looking at the specs here, it's immediately clear this is not consumer gear. This is made for what they call a modular matrix environment.
Which is a concept I just love. It's basically future-proofing, isn't it? Instead of buying some fixed switcher that you have to toss out in 3 years,
Right.
you just have a chassis, like a blank canvas, and you can just swap these cards in and out as technology changes.
That is the whole strategic advantage. It changes your AV setup from, a massive capital expense every few years to more of an operational thing. The MC3-2HO is designed to, as they say, flexibly occupy one of those slots.
So a system integrator could build a totally custom rig.
Exactly. Maybe you need, 12 outputs for a wall of screens, but only 4 inputs. This lets you build that.
And it's not just pushing any old signal. I mean, the big headline here is 4K 60, 4.4.4. Okay, so for anyone listening, seeing 4K is one thing, but that 4.4.4 part, that's a heavy lifter, right?
That's everything. It means no chroma subsampling.
Explain that.
Sure. So in video streaming, like when you're watching Netflix, they compress the color information to save bandwidth. They drop it to something like 4.2.0. You barely notice it in a movie.
Okay.
But if you're trying to project a complex CAD drawing or a giant spreadsheet, that compression makes fine lines and text look blurry or even jagged. This card sends the full, uncompressed color detail for every single pixel.
But to move that much raw information, you need a huge pipe.
An enormous pipe. We're talking about 18 gigabits per second of bandwidth.
Wow.
Yeah, if a normal HDMI is like a garden hose, this is a fire hose. It's about 6 GDPs per graphics channel. That's the kind of headroom you need for things like HDR10, deep color, and all that.
I did see it supports 3D, which, feels a little niche these days.
It does, but some sectors like medical imaging or high-end design, they still rely on it pretty heavily.
That's a good point. But okay, let me play devil's advocate for a second. I'm looking at the distance specs. It says it can send that full 4K 60 signal up to 10 meters. That's, about 32 feet?
Yeah.
In a big commercial building. Isn't that kind of short?
It is a limitation. That's just physics. When you're pushing 18 gigs over copper with zero compression, you're going to hit a wall pretty fast. So yeah, if your equipment rack is 3 floors down, this card alone won't get you to the display.
But you get a bit more slack if you drop the resolution.
Right. Drop it down to 1080p with deep color, and you can push that signal out to 15 meters, so almost 50 feet. It's that classic trade-off.
Mm-hmm.
Do you want maximum distance or do you want maximum pixel density? This card is all about density.
And all that bandwidth isn't just for what you see. It opens things up for what you hear, too. I saw it supports 32 channels of digital stereo uncompressed signals.
Mm-hmm.
That feels like complete overkill for a conference call.
Well, it's not really for a conference call. The 32 channels are what enables object-based audio. We're talking about support for really complex setups, maybe Dolby Atmos or spatial audio in a simulator. It handles Dolby True HD and DTS HD natively.
So you're getting audio immersion that actually matches that visual quality.
Precisely. And what's really surprising is that it does all this with a power consumption of only 5 watts.
That's wild. Now let's talk about the price. The list price is around $1,240, though you can find it for just under $1,000 for a single card. That's a serious investment.
It is, but you have to compare it to the cost of failure. In a live broadcast control room, a screen going black costs a lot more than $1,000. You're paying for reliability and that CE safety compliance.
And the whole ecosystem, I suppose. Kramer calls itself a 25-year global home, and this thing comes with a 7-year warranty.
And that warranty is key. It tells you they expect this piece of hardware to last well into the next major technology cycle.
So to wrap this all up, we're looking at a card that weighs about half a pound, but it's this incredibly powerful engine for distributing, uncompressed reality. It's handling 18 GBPs of data just to make sure our text looks crisp.
It really puts into perspective how demanding our visual expectations have become.
It really does. And it leaves me with this final thought for you to chew on. We are pushing the absolute limits of our copper infrastructure just to handle 4K.
Yeah.
As we start to look at 8K, real VR, and whatever's next, you have to wonder, is the future of AV going to need a completely new kind of plumbing? Or are we just going to need bigger and bigger fire hoses? Thanks for joining us on the deep dive.